Thank you. Thank you so much. This is one of the afternoon sessions, typically a tough one, because you have been consuming so much since morning, and people start dozing off by this time. So hopefully I'll keep you entertained. My name is Arun Gupta. I work for Amazon. I particularly work in the open source team at Amazon. And this is mainly targeted towards Java developers, but this can definitely be applied to anybody who want to get started with Kubernetes. So this talk is about Kubernetes for Java developers, and there are no slides here. No live coding as well, but essentially this is a repo that I've built on how should Java developers look at Kubernetes. I'm building my applications using Spring Boot. How do I get started with Kubernetes? So what are the tool chain that I need to look at? How does my existing tool chains work with it? So please take a note of this GitHub repo. Everything is over here. So let's get started, okay? If you were to look at sort of what are we going to talk about, well, I, of course, have my application, which is a simple Spring Boot application. By design, it's a hello world application. Then we talk about how do you build and test using Maven. So that's my first step, which is basically my Java application. So I'm going to get a feel for that. Then I do the exact same thing with Docker. Well, why Docker? Because when you have your Java application, the first step in your journey to Kubernetes is to Dockerize it. And there are lots of different ways by which you can Dockerize it, and we'll explore some of those. When you're using Docker, what JDK-based image we should be using, and how we should look at, what are the patterns and design patterns and anti-patterns that I've seen. So I'll share about those. Then you come into, all right, I want to get started. I have the Docker image. What does it take for me to get started with Kubernetes? What are my options? Can I run Kubernetes locally? Do I need to run it in the cloud? How do I create a Kubernetes manifest? All those things. What are the Kubernetes concepts that I need to understand? Then I eventually start going from development to production. And now my Kubernetes cluster is running in the cloud. Now I want to say, hey, by the way, take my application that was running on my local environment to the production environment. And then once it's done, then I'm looking at other fun things. That, OK, I want to do A/B testing, canary testing. I want to set up a deployment pipeline. So I'll cover a bunch of those aspects as well. Okay? Now, don't worry if I'm not able to cover all the concepts. Usually, depending upon the pace, we are able to go all the way up until migrate from dev to prod. But all the content is here for you. So you can actually start looking at it by yourself at your own pace and try out these samples. That's sort of the whole premise over here. Okay? So let's get started. First thing first. I'm going to look at my app here. So this is my application. In here, let's look at my basic application here. So this is a standard Spring Boot application, so nothing fancy in here. But if I look at greeting controller, this is where my powerful application is. All I'm doing here is hello. Well, you guys know how to write much better Spring Boot application, so I won't dig deeper into it. But when I see hello, that is my happy moment. Every time, whether I'm doing Maven or Docker or Kubernetes, again and again and again, I want to see that response. Because that shows that I'm making progress in my development cycle and getting the exact same response. Okay? If I look at my pom.xml here, usual pom.xml for a Spring Boot application, nothing fancy in here. We'll cover some of these properties later. I have the Spring Boot Maven plugin that allows me to run it. And we'll talk about this Jib Maven plugin a bit later. So now, let's go to Kubernetes for Java developers. I go to app. OK. Wrong one. So if I go back to my instructions here, okay, in here it says, I just go to cd app, and I say Maven Spring Boot run. So I'm literally going to copy-paste the command so that that's what you get used to as well. So all I do is Maven Spring Boot run. If it has not downloaded the internet, it will download internet now and run my application. Okay, so now the application is up and running. So what I'm going to do is I'm going to open up a new tab here. Go to my browser. Application by default is running on localhost /8080 and /hello is my URI, okay? So I type it here, and I see hello. That's the response I care about. Happy moment, so it's looking good. All right? Let's go back here and terminate the application here. So that we free up our port. So that's sort of my basic application here. OK, now let's take a look at it. How do I Dockerize? That's my first step. Multiple ways, OK? You can use a Docker file. That's the usual way customers look at it. And what is Dockerfile? Dockerfile is basically a starting point on how will you create a Docker image. And in Dockerfile, you put a bunch of instructions. And that syntax is all available on Docker docs. So you go Dockerfile docs. And if you go here, it gives you complete reference on Dockerfile. What are the syntax that can go in here? To begin with, it could be daunting that what should I use, what should I not use? And let me tell you why it is daunting. I searched for Dockerfile docs, and the second link itself is best practices. And best practices, it smells like an issue to me. It's like a bug. It's like, oh, these are like 19 different bugs here, but here are best practices by which you can avoid the bugs. So the moment I see best practices, I mean something is missing in the basic product itself. Anyway, so you saw the syntax here, but we'll talk about it. But what I'm doing is the way you have a Docker file. In the Docker file, you put all the syntax. And in Dockerfile, you say, here is my base image. Because in the base image, you say, here is my operating system, or OpenJDK as a base image. And then on top of that, I'm going to start doing some things. And what is the advantage of a base image? In the base image, it gives you tools that are available to you automatically. That base image could be from Docker Hub, where millions of images are already available. Or that base image could be generated by you or by your IT team, which is installing your specific images as well, or your specific tools. So for example, your IT team might have taken OpenJDK as a base image, or Corretto as a base image, or Ubuntu as a base image, install certain tools over there, and then say use that as a base image. So if you use that as a base image, on top of that is where you build your application. Okay? Now in this case, I don't want to download Maven every time. So what I'm doing is I've downloaded the Maven repo for my project, and I'm loading it into the Docker image itself, pre-populating it. And then I say Docker image build, Arun Gupta, which is my image name. So I'm saying Docker image build -t. I've got to give it a tag, and I say dot, and which is sort of the context where Docker file is sitting. Okay? Now, if I open up this URL here, let's go back to my app. Let's look at my Docker file here. So let's look at what the Docker file is doing here. Now, on line 1, I'm using Maven as a base image here. Okay? And to Maven, I'm giving the tag 3.5 JDK8. That's the image that I'm using. Then I'm saying take m2.tar.gz from my local machine, copy it into the /root directory of the container, of the image. Then I take my application, copy it in there, and then I run Maven in interactive mode. So that is sort of my first stage. By default, you can have one stage, which is like the beginning of the from line on line 1. And that's my stage 1, and I'm giving it a name build. So what I'm doing is I don't need to have Maven on my local machine. In this case, I'm using Maven as a base image, uploading all my dependencies into the image itself, and I'm saying use that base image because that base image has Maven tool installed already. So use that as a base image and build my thing up in the Docker image itself. But now, think about this. If you are using Maven in there, do you want all those classes and jar files to be available as part of your final image? No, because then that bloats your image. So that's where your multi-stage Docker file comes in handy. In this case, on line 8, I have a second from statement. So what I'm doing is I'm saying create a new image from here. So it's basically 2 stages. In the second stage, I'm saying use OpenJDK or 8U171 Alpine as a base image. Much smaller, much leaner, and I can actually use the JRE here. I don't need JDK at runtime. All I need is JRE. And that's a common, very common design pattern I've seen, or rather anti-pattern that I've seen customers where they're using JDK as a base image. Think about it. Do you really need JDK at runtime? You're not still building applications with JSP where you need to compile them to servlets. I hope not. In which case, you can use JRE as a base image. And if you use JRE as a base image, it automatically cuts you down. So then you're doing on line 10, you're saying, from the build stage, pick up the target directory, copy it into my local machine, set up a work directory, set up your Java options, whatever you're doing in a usual way, run it, java-jar app.var. This is one fat var file, one fat jar file, but then you can run it this way. So very usual Java commands, but that's what you're doing over here, okay? So let's try it out. So I'm gonna copy this command here, go to my terminal, Docker image build, and by the way, here is my Docker file that we were talking about, so it's right here, exact same thing. So it's gonna download the context, download the latest images, and by default, it downloads the images from the Docker Hub, and then it builds my Docker image. Now it's running Maven in there, and it's not gonna download the internet because it's already provided in there. Some parts it does, but once it's done building the image, then here I can say Docker image ls, for example. I do have a lot of greetings here, so give me a second here. So this is the kind of thing exactly you want to avoid here. You don't want, because every time you build the image, every time it's going to download Maven in your image. You don't want that to happen. So we'll come back to this. So once it's done the image, then, well, that's one option. The other option is, hey, I saw best practices. I don't want to go that route. I don't know what are the best practices. I'm reading too much on to getting started with. I'm a Maven. I use Maven, Gradle, and things like that. I want to integrate something into my build cycle itself. If I'm using POM XML, I want something in my POM XML as a profile by which I can say Maven package, I give it a profile, and then it'll build my Docker image as well. That's where tools like Jib are very handy. Jib is an open source tool, open source plugin of Maven. And all I'm saying is Maven compile jib:build, and that's where my profile is. So let's go and take a look at my app here. We saw this earlier. Actually, POM XML. I've added a Jib Maven plugin here. In there, I'm saying use OpenJDK as my base image. That's image that is I should know about it. Create an image name. Specify these environment options and port, and tie the build and the package phases together. That's it. Okay? So once I do that, then Jib will take an opinionated approach. It will automatically create your Docker image. Everything kind of stays as part of Maven. And of course, there's a Gradle plugin as well. But then, the moment you give the command Maven package -p_jib, it'll now create a Docker image for you. So let's go back if it's done downloading. There you go. So now the thing is done downloading here. So let's clear it here. And if I grab on greeting, it says about a minute ago, and here is my Arun Gupta greeting image, about 490 megabytes. So not too bad. Well, that's Java, guys. Sorry. Now, I've listed what are some of the advantages of using Jib here. If you use a Docker file, for that, you do need Docker engine installed on your local machine. Certain times, you don't want to install the Docker engine. You want to build it directly to a Docker repo, for example. Docker Hub, ECR, whatever, doesn't matter, right? So that's one of the advantages of using Jib. Jib can optionally build to your local Docker engine, or it can directly build to your Docker repo itself. And it's much faster. It builds reproducible. Now, think about this. When you're building your application, in a Spring Boot kind of an application, what changes the most? The application code. Now, every time you change application code, what is it? The way Docker image is laid out is it's a set of layers. Okay, it says here is my base operating system layer. Then here is my JDK layer. Then here are my tools. Then here is my entire application. By default, if you use Dockerfile, it takes that one big fat jar and put it as a layer. So your application code is changing, but every time you're building a Docker image, that entire fat layer is changing. One of the advantages of Jib is where it takes your jar file and breaks it into further layers. It says, oh, here are your dependencies, here are your jars, here is your application code. So with Jib, your application code becomes a layer. So the advantage of that is every time you build it, that's why it builds much faster, because it's only rebuilding your application layer, and that works out very well. So once you have done it, then what we're going to do is we're going to run this command here, copy it. So I'm going to run it, docker container run, -- name, give the container a name, and I need to forward the port. So 8080 on the host to 8080 in the container, because we already exposed that port. And I'm going to run it in a background mode, and here is my container name here, or image name. So Docker. I'm going to remove all the containers that I have here. Delete. OK, now let's run the container again. OK, so now my container is running. So what we'll do is, this is the command that we saw. We were familiar with this one. All right, so same command now. Now I'm going to invoke it. And of course, it gives me empty here. So docker container ls. Yeah, this has been up and running for 16 seconds. Let's try it again. Yeah, now it gives me hello. Again, a happy moment. So let's look at the journey here. You built an application using Maven, got a hello response. You build the same thing using Docker, and you get the hello response. So very simple regression test, but it's passing at least. So let's see what's the next thing in our journey. Well, another key part that you want to understand is we looked at the jar file, which was about 490 megabytes, or the Docker image with 490 megabytes. Now, in a microservices world, you have multiple nodes where this Docker image needs to be downloaded, or you are scaling your application up and down. So if you are scaling your application up, then this Docker image needs to be downloaded on the fly to a particular host. That's a big image. Hopefully, it works fast with the internet. You can't rely upon it. So that's where in JDK 11 particularly, there is this feature. JDK 11 doesn't ship with the JRE, as a matter of fact. So what you do is you create your custom JRE. And so what I'm showing over here is how you can create a custom JRE for your Spring Boot application. And we are using tools like JLink and JDeps that allows you to create that. So first of all, here I'm saying JDeps, print the module that my app.jar depends upon. These are my application-specific modules, and this is from the JDK. Then, in addition, I'm saying, I know these are the modules that Spring depends upon. Add those modules in as well, because that needs to be part of my custom runtime. And then I'm saying, JLink, take that list of modules and create my custom JRE. That is super cool, because now I don't want things like Corba, as a matter of fact, when I'm writing a Spring Boot application. And my first job when I joined Sun Microsystems back many years ago, almost 20 years ago, actually over 20 years ago, yeah, when I joined Sun Microsystems, was a Corba test engineer. So I do have a special affection and love for Corba. But as much as I like it, I don't need Corba here. So now I'm creating my custom JRE. And if you see here, I'm using a dockerfile.jre to do the same thing. So let's go back here, look at Dockerfile JRE. I'm just using Debian 9 Slim image. I don't need Maven, none of that. I copy my custom JRE to the app. From that custom JRE, I can run my jar file now. Exact same thing, but it makes the entire process a lot simpler. And so let's go here. Actually, this command will not work here because I don't have JDK 11 installed on my local machine. But the idea being, if you run it, now you have two images here. There is First one, which is Arun Gupta /greeting, which has a JRE slim tag, and the second one has a latest tag. Look at the size difference on the far right over there. It's less than 1/3. That's the image that I'm looking at here. Now, I gave a talk at last year DockerCon with one of the Oracle engineers, and there we literally took this image, got it down to very bare minimal. Like a simple Java hello world, we got it down to about 20 megabytes Docker image. But it had no debugging information, none of that. Now, you don't do that in production, but we can, if need be, you can start stripping it down. So that I think if you're looking to optimize your Java images, looking to optimize your Java Docker images, that is a good session to look at. So always consider if you're using JDK 11, how can you use custom JRE to trim down your Docker images? OK, so let's go back here. And what I'm going to do is Docker container rm-f hello. Oh, what was my thing here? Greeting, actually, not hello. If I can type correctly. Yes, that goes away. All right, now, what's my next step? So I got my Docker image ready, push it to Docker Hub, ECR, whatever is my favorite repo is. Now, I need to get started with Kubernetes. Well, first option is you don't just start with Kubernetes wherever you want to. As a developer, I want to try it out on my local desktop first. Okay? What are my options for firing up Kubernetes on my local desktop? The most common one that I've seen people using is Docker for desktop. So if you have Docker engine up and running on your machine, it's as simple as, so this is my Docker engine up here. I can go to, say, preferences. And there's a Kubernetes tab here. And you just say enable Kubernetes. Docker desktop is running. Kubernetes is running. It's a single node Kubernetes cluster that easily fires up on your machine. Works very well. Okay? So that's one option that I've seen customers using. The other common option is where you use Minikube. Minikube is, it uses VirtualBox as the underlying VMM provider for you, but then it provisions a single node Kubernetes cluster on your machine. Either way, you have a single node Kubernetes cluster running on your machine, and you can start that with testing. Or if you really want to go big, then maybe you go on AWS and say, give me an EKS cluster. And we'll talk about that in a second. But now you have a single node cluster running on your machine. So what do you do next? You could have multiple clusters installed, a single node cluster on your machine, multiple clusters on your cloud. And all you need to figure out is, well, you need a tool called as kubectl or kubectl. That tool really allows you to talk to your Kubernetes cluster. So once your Kubernetes cluster is up and running, you brew install Kubernetes CLI, and you need to configure the Kubernetes cluster that, OK, this kubectl is going to talk to such and such Kubernetes cluster. Then you take that Docker image that you created, and you're going to create what you call as a Kubernetes manifest. So let's talk a little bit about what are the Kubernetes resources that you need to be aware of. First of all, Docker is the language that Kubernetes supports, but the lowest level of deployment unit in Kubernetes is a pod. And think of pod as a wrapper around container, and a pod could have one or more container, usually one, but if you get into logging and things like that, then you could inject multiple other sidecar containers over there. But for practical purposes, for now, let's say you need a single container, and pod is a wrapper on top of that. So you need a pod. Now, you generally don't deploy the pod directly. On top of pod, what you have is a deployment. So you create a deployment manifest, which has the pod specification in there. And then you say, create 5 replicas of my pod. One of the advantages of Kubernetes is when you say, create 5 replicas of my pod, Kubernetes makes sure that there are 5 replicas of pod running. And you can define health checks. You can define, a pod is unhealthy if it's using more than 80% of CPU, or a pod is unhealthy if the response time from my web page is taking more than 50 milliseconds. So you can define your application-specific health checks, whatever. You can define those health checks, and that's what defines a pod as a healthy. Now, What happens if a pod becomes unhealthy? Well, Kubernetes terminates it, fires up a new pod. So it just bounces the pod automatically. So all of that is available to you by default. But what you need to do is write a deployment manifest within which you define your pod, within which you define your application metrics. Now, pod, every concept that you create in Kubernetes is typically given an IP address. Pod is given an IP address as well, but it's accessible only inside the Kubernetes cluster. So, and if a pod terminates, the IP address goes away, and the pod may come up on a different node, maybe given a different IP address. So what do? Well, you can't refer to a pod directly, but that's where you need a referenceable name. So you create a pod, you create a deployment, and then you create a service on top of that. Those are the three concepts you need to understand to begin with, at least. Now, usually, most of the times, you're OK going quite far with those. So you create a service, and service is basically a referenceable name to the pod. And how they are connected to each other, each pod is given a label, name-value pair, basically. So you can say name : my app, just a random name-value pair. And then once you assign a label to the pod, to the service, you say, pick any pod that has that label. OK? So once you understand that basic concept, then you have a deployment created. To the deployment, you say, have 5 replicas up and running. And then the service says, pick any pod as part of that label. That's it. So now your service is accessible. Now your pods are scaling up and down behind the scene. And you have all of those manifests written together. Let's take a look how that will look for our application. So here is my greeting deployment, for example. This is an example of a Kubernetes manifest here. So I'm saying API version. I'm defining what my deployment looks like. I'm giving some metadata here. I want a single replica of the pod. And I'm saying, in this deployment, have any pod that have the labels app : greeting. Down here, this is my pod spec here. This is my pod spec. And I'm saying the name is greeting. The image is Arun Gupta / greeting. I can define an image pull policy. And I can expose the ports. Okay? So this is my deployment and pod spec combined into one. In addition, now remember, the labels here are actually in the metadata section, app : greeting. And if I look at, say, greeting service here, I'm saying selector is app : greeting. So that's how the pod and the service are tied to each other. Another part to notice here is, in service, I can define a type optionally. And in this case, I'm saying type : load balancer. And where is it handy? Let's say I want to expose my service publicly. Remember, I said service pod, everybody that is created in Kubernetes is assigned an internal IP. But now, I want to publish my service outside my cluster so that my customers can access it. So the moment I say type : load balancer, depending upon the kind of cluster where the service is provisioned, an IP address will be assigned to it. If I'm running it locally, that'll be localhost. If I'm running it in the cloud, for example, AWS, that'll be elastic load balancer for me. So really, it's as that simple. And that's the beauty of the Kubernetes API here. Exact same manifest, depending upon where you are deploying it, will have the IP address available to you. And you can actually use the same querying mechanism to access the service here. Okay? So what are we doing here? First of all, let's take a look at it. kubectl config get context. So it's showing me that there are 4 clusters running for me, essentially. I'm running a GPU-based cluster, which is typically used for machine learning, and we're not going to get into that. But then I have Docker for Docker desktop, and Docker for desktop, and Minikube. So I have multiple clusters up and running over here. Okay, so I can say kubectl config use context. Well, actually, let's do this way. kubectl get nodes. I want to see in my Kubernetes cluster how many nodes are available. So now this is going to talk to, well, it says star over here. So that is my current cluster. So it's showing me that there are 2 nodes that are running over there, and they're about 10 days old. And now I can say kubectl config use context. I think it's Docker desktop. I don't know why there are 2, but Let's try this. If I say get nodes, OK, there you go. So this is one single Docker desktop node, been running for about 90 days. And that's the version of Kubernetes here, OK? So now, if I have my greeting deployment and greeting service, I can say, show me the deployments that are running. Well, there is apparently one running. So let's go ahead and delete this deployment. And I can say my app-greeting. Oh, not app, deployment. Again, I cannot type. I guess it's 5 in the morning back in the Bay Area. Deployment. Wait. Go away. All right. And then I can say, show me the service that is running. So kube control get service. And there's a service that is running. So similarly, I can say kubectl delete service dash my app greeting. Okay? So I've deleted my service and my greeting. So let's say, let's get service and deployment again. None of them is running. Okay? So now I can say, hey, take this kubectl create dash f. I'm going to specify it a manifest. And in this case, I'm going to say deployment. So that's going to create my deployment again. And then similarly, I can say create my service, and that creates my service again. So let's query the cluster again. Service and deployment, they're both running. So here is my service. Here is my deployment here. Now let's try. And if you see here, this is actually giving local host. Okay? So because I'm running it locally here. So now if we try our curl command here, requested resources not found. Oh, the port is actually 80 here, not 80. So here you can see the port is 80. So let's try that. OK, bingo. So I still get my hello response back. So let's go back to our Kubernetes journey then. I had a Docker application. When I had a Java application, created a Docker image out of it, wrote my Kubernetes manifest, service and deployment, and part spec, and then ran my cluster, and then deployed that manifest in there. And my application is now up and running in the Kubernetes world. That's kind of cool. Now, more often than not, your application is broken. And you need to debug it. What's going wrong? How is it happening? All that sort of stuff. So that's where I can start using the usual Java options, set up my debug options in there. And remember, we set up those debug options in my Docker file. So all I'm doing is I'm enabling the debugging of my application in there. So in IntelliJ, for example, I can actually even here, as a matter of fact, here you can see I'm only exposing port 80. So I cannot really do the debugging here. But depending upon what my manifest looks like, I can expose that 5005 port, which is the default port that IntelliJ exposes for you. And then I can connect to the VM and start debugging through my application. And what I'm going to do here is I'm going to just show you a snapshot and not show it. So if you go to IntelliJ, you can say run debug remote. It shows you the JVM options. You drop those JVM options in your Docker file. And then now you can start debugging through your application. Okay? Pretty straightforward. So now you have your application up and running. What do you want to do next? You want to really take your application and deploy it to the cloud. Well, there are lots of ways by which you can deploy it to the cloud. The CNCF, or the Cloud Native Computing Foundation, latest survey says over 50% of Kubernetes runs on AWS cloud. Of course, I work for AWS, so that's the service I talk about. So we have a managed Kubernetes service, Amazon EKS, or Elastic Container Service for Kubernetes. You can go to the console, create a managed Kubernetes control plane, bring your data plane and attach it to it. Or what we recommend to our customers quite heavily is to use EKS Scuttle. That's a tool that is created by one of our partners, and it's going to soon be available as part of our formal documentation. But really, all you do is reinstall vworks EKS Scuttle, and you just give this one command, EKS Scuttle create cluster. You actually don't have to give any of this. This is optional. I'm just specifying the values here so that you understand. But here what I'm doing is I'm creating a 4-node Kubernetes cluster for you in the region US West 2. And you can look at Kubernetes is available in a wide variety of regions, so wherever you want to start. And then you can say kubectl get node. So if I go back here, kubectl config get context. I can switch back to this particular. This is the one that is running up in the cloud as well. So now, think about what does your cycle look like from development to production. It's pretty straightforward. You use the command kubectl config use context. You switch the context, and you run your commands all over again. You take the same development, deployment, same manifest, and run them on the cloud. And that really allows you to deploy the same services up in the cloud. So if you go back here, get the context, migrating is use context, run at my EKS US West 2, and you can deploy it over there. Okay, so I'm going to look at this part a little bit later. Well, actually, right now. So now think about your microservices-based application. As you are writing microservices-based application, you will end up creating services and deployments for each of your microservice. Now, managing those and creating those, issuing those kube control command becomes very challenging. That's where the concept of Helm comes in. Okay? What is Helm? So Helm is an application development chart. So what you do is you create all of these services and manifests together as part of a Helm chart. And that Helm chart sort of becomes your application definition, essentially. So you can take that Helm chart, and you can deploy it to your Kubernetes cluster. All those services and manifests gets created for you. And you can delete that Helm chart, in which case all of those manifests gets deleted as well. So if I look at, say, manifest here, and look at, say, my app, this is how my Helm chart typically looks like. So I have a top-level chart.yaml, which kind of gives me the little bit of a description for the chart. Then I have values.yaml. I can define all my static constants here, for example. And if I look at my templates.yaml, I look at greeting deployment, for example. And remember, I can use a templating language here. And that's the advantage of using a Helm chart, because it gives you a little bit of a consistency that what my image names are going to look like, how many number of replicas, what kind of ports, et cetera, I can use. Because I'm defining them in my top values.yaml, and I'm using them as a template over here. So in this case, for example, I'm using the template labels, which are defined in my values.yaml up there. Okay? So you define your same thing. You define your deployment and service using that templating language. And now you just install Helm. And to Helm, there is a client component, which is a Helm CLI. Or at least in Helm 2, there's a server component called as tiller. So you install the Helm. You basically say on your Kubernetes cluster, Helm init. And, well, you install the Helm CLI on your local machine first. And then you say Helm init, which basically installs the server-side component in your Kubernetes cluster. And now Helm is initialized, which needs to be done only once. And once you have done that, then you can say Helm install, give it the application name, and provide the top-level directory of where your Helm chart is available. So the application deployment becomes a lot simpler, because you're all putting it all together as one package. Now, remember, we talked about the concept of pod. Pod has one container. That is the usual use case. But what is the whole concept of a service mesh? Where do you need it? Now, imagine your application is deployed. You have deployed one version of the application. Now you want to deploy a new version of the application. And you only want to guide, say, 5% of the traffic to this new version of the application. How would you do that? Well, there are lots of tools by which you can do that. But that whole, so what you do is, in your pod, you inject a sidecar container. And so what happens is that sidecar container is the one that controls your network traffic. So essentially, if you are talking to the application container, you talk through the sidecar container. Or if the application container wants to talk to any other application container, it talks through the sidecar container. And the advantage is, well, first of all, in a pod, if there are multiple containers, they can talk to each other using localhost. They share the network, file system, all of that. So when the sidecar is talking to the application container, they're talking to each other using localhost. Because the network traffic all goes through the sidecar container, you can exactly define which application can talk to which application. So now, well, Istio is one of the service meshes that is available. And you can install and configure Istio very easily on Amazon EKS, which is our fully managed service. And the steps on how do you install Istio are available over here. But once you have installed Istio, what you can do is in your Kubernetes namespace, you can say any pod that is installed in that namespace automatically enable sidecar injection. That means from the Helm chart, you're installing the pod there, but it will automatically inject a sidecar container as part of that pod. Okay? So now when you are saying kube control, get me the pods, only the greeting pods, the main thing that you're looking for over here is 2 by 2. What that means is there are 2 containers in the pod, and both of them are ready. Well, one is your application, and the other one is a service mesh, or the sidecar container. And if you see the list of the pods that are available, the list of the containers that are available, greeting and Istio proxy. So now, imagine this application up and running in the cloud. So what you're using is kube control, get me service/greeting, give me the status, load balancer, ingress 0, host name. You get that name. So let's take this command here, for example, for a second. And we are still on Docker desktop, and give this command here. Well, let's see, what's our service name? Kube control get service. Yeah, the service name for us is greeting service. Okay. So if I give this command, it's giving me local host here. If this cluster was up and running in the cloud, the same command will give me the ELB address. So you can start, as I remember I said, you can start accessing your application using these commands. So now you are accessing this. So now how does my traffic shifting works? Or how do I do A/B testing here? Now I've installed Istio, my sidecar container is injected. There are resources that Istio defines, like virtual service, and where would the traffic go really. So if you look here, for example, let's go back to manifest here. I can define an app rule. So I'm defining a virtual service here. In the virtual service, I have 2 destinations, greeting hello and greeting howdy, and I'm assigning weights to them. And in the weights, I'm saying, give 75% traffic to the hello one and 25% to the howdy one. And how are they identified? If you look down here, the destination rules, they're really identified by the labels. So labels is a very powerful concept that allows you to keep these different services loosely coupled. Okay? So in here, I can easily change that to, say, for example, I don't have one for 90-10. But fairly straightforward. I can just change this weight to 90 and 10 or 95 and 5 and start looking at it. And the idea is that you can set up metrics that gradually scale this up based upon my metrics. If I'm getting good response from the app, app howdy or greeting howdy, scale that up and bring that one down. So you can scale the traffic. And these commands can be issued using kube control as well. So you can say, change the weight from 75 to 90 or 75 to 60 if I'm getting good response and if the service is looking healthy. Now, there are a lot of things that you can do here, and I'm showing some examples over here. How you can run about 10 instances, and you'll see the traffic being split 75 and 25%. Same way you can do canary deployment. It also gives you distributed tracing, that my greeting is going through different microservices, and how does that deployment look like? So it kind of gives you a nice chart over there. You can do metrics using Grafana. Those details are available here as well. Now, the last piece that I quickly want to talk about is setting up a deployment pipeline. Hopefully, you are not directly deploying from your developer machine to a Kubernetes cluster. Good for development, but for production, you're really thinking in terms of that, here is a GitHub repo, here is a commit notification, take that commit notification, and then deploy it to the cluster. Or check out the master, or check out a branch, and then deploy it to the cluster. So now there are tools like Scaffold. Scaffold allows you to manage a deployment pipeline local on your machine. So definitely take a look at that. And in this case, you can just download Scaffold and get it started and up and running with it. Or you can use tools like Jenkins, of course. Jenkins X particularly. Take a look at that. And today is 27th. 30th, on April 30th, there is a Jenkins X virtual conference that's happening, which is dedicated towards how do you bring your Kubernetes application and run CI/CD on them, particularly using Jenkins and Kubernetes. So this is a virtual summit. Definitely encouraged to attend that. I have a session over there as well. But if you are trying to set up your deployment pipelines using Kubernetes, Jenkins X is definitely a credible tool that you should be looking at. And of course, if you are an all-in AWS customer, then we have code deployment, code pipeline, all of those tools available at your service, which are fully managed service. And that's the aspect that customers love about it. So really, as part of your cloud formation, you can say, create those resources, and now manage all of that for me in the cloud. Okay? So let's go back to the beginning here. Well, this is a GitHub repo that we talked about. But essentially, you build and test using Maven, then create your Docker file. We looked at the patterns and anti-patterns that should be used, how you can run it locally using Kubernetes, how do you debug and test, how do you move your application to the cloud. First of all, set up your cluster in the cloud. We talked a little bit about sidecar containers using service mesh, and then we talk about deployment pipeline. One of the aspects over here is also about how can you cause chaos, test your application for resiliency, and that's a whole topic by itself, so I won't dig into it. But hopefully, this repo will give you a good idea on how you can get started, particularly as a Java developer. You want to learn the tools. And I know this repo was updated about a month ago or so, so I'm planning to add more examples here. If there are any other concepts that you think are missing, I would definitely encourage to file issues over here. And something else that I want to find is also a course that I developed recently. It is basically Kubernetes for Java developers. And this is, it's available 30-day free preview. And you can look at the entire course. It's about 2.5-hour long course, which really allows you to get started, and get that feeling. It provides in that 2.5-hour fully end-to-end experience for a Java developer. Well, that's all I had. I'm going to be outside. So if you have any more questions, your specific use case, I would love to talk to you and help you get started. Thank you.